part of the Yahoo placemaking technology. And he has moved on to create many more new things that, for example, related to Google's secret television, and also he's working on the AdSense. So let's let him to talk more. I hope that you can enjoy the evening. I have expected.
Let's get started. Thanks, Dal.
Yeah, okay.
Hello. Hi, everyone. Sorry again for the delay. It's really good to be here and to speak again. It's my second guest lecture, so the second attempt. Don't be too harsh on me. I'm not a professional lecturer like Dal, who's done God knows how many lectures. Anyway, today's lecture is called Google Cloud Endpoints, third-party APIs on Google App Engine. Now, there are probably a lot of buzzwords, but everything will be explained in due time. Now, few things before we start. Oh, bugger. We probably need to do this. No, doesn't really help. Okay, I will read titles aloud. So the first slide title is Hello World. My name is Roman. When you say Mr. Kirillov, I get nervous and I start looking around looking for this mysterious Mr. I'm not familiar with him. If you have a question, raise your hand. I'll try to answer as I make a pause. And there will also be a dedicated question and answer time in the end of this lecture. So hopefully the lecture will be about 35 to 40-ish minutes. You will probably want to ask some questions about Google in general, not related to this lecture. That will also be fine, but please hold on and wait for this dedicated Q&A time. And finally, all the source code, there will be a source code in this lecture, will be provided at some point in form of GitHub link. This code exists, it's just ugly thin, and trying to teach you something, I just don't feel like showing this code will teach you anything good. But hopefully it will be ready soon. So, today's plan. First we're going to discuss what are APIs in general, what are web APIs in particular. We will talk a little bit about the structure and architecture of web API and what does it take to build it. Then we will move on to how can you build APIs using Google Cloud Endpoints on Google App Engine. And finally, we will touch consuming this API, so building API clients. Hopefully we'll have enough of time for this. Right, off we go. So, Bill, what's the subject name? Is it cloud computing or something?
Yeah, cloud computing, and also cloud computing concept.
Wonderful. Would anyone please tell me what is cloud computing? Raise your hand. Give me an answer.
Building castles on the cloud.
Right. Anything closer to technology? Anyone? Come on, guys. I won't give you bad marks or good marks for that matter. Anyone? No one? Okay, Del, you have to answer this. Just give us a textbook definition.
I don't really have.
Okay.
It's hard to say. There are several characteristics.
Okay, here we go again. Anyway, for the goal of this lecture, let's try to think of cloud computing as a situation where data lives remotely somewhere. The functionality lives remotely somewhere. And the batch processing also lives remotely somewhere until someone wants to come in. They all live remotely. Now, let me give you, in my opinion, a great example of a little app which exists for pretty much every platform, which exercises this concept. So here you go. The app is called Astrid Tasks. Maybe you heard about it, maybe you haven't. But basically, it's just a task manager which has a web UI, a mobile web UI for that matter, have normal web UI. Here you have Android application. There are also applications for iOS, BlackBerry, maybe even this thing called Windows. I don't know if you heard about it. Right, but the point here is the way data is represented to the user is very different. Just compare web application and native Android application. There's nothing in common. The way we handle input is different. But the thing is, the way data is stored, the way data is manipulated, the way we access this data is effectively the same for every platform. And one more thing you should probably consider, if you think about any Ajax application, with any Ajax application, you basically don't have, you basically separate server-side logic and client-side logic, so you work in a client-server model. So here, you deal with a thing called API. The server side of this application, the cloud side of this application, provides a well-formed API which clients use. And it doesn't matter what kind of client is it. It can be a mobile web application or Android application or iOS application. They all use identical API, which makes it very easy to develop a separate server part and a separate client part. Now, do you remember I asked you what's the definition of an API? And nobody gave an answer. Even Dell didn't. Right. Here's a textbook definition of an API. It's from Wikipedia, really. So, the application programming interface is a protocol intended to be used as an interface by software components to communicate to each other. It all sounds really great. Now let's try to rephrase it in plain English. So the API is a layer which exists between two components or between two applications which allows them to communicate to each other via some well-defined interface which completely hides details of the implementation. The API on its own is a very, very broad, complex concept, and there are lots of well-known examples. Just to give you a few, think Java Collections API. When you work with Java list, you don't really care how is it implemented inside. Is it array list? Is it linked list? Or is it something even more esoteric? You just work with it as a list, and the specific implementation doesn't matter. OpenGL. When you work on your super-duper free game, you don't really care how specific NVIDIA or ATI card implements drawing graphic primitives on a screen. It's just too much detail for you. So you work with some high-level interface which allows you to draw something, and this interface handles all the communication with the downstream layer, with the hardware. And I think you've been dealing a lot Hadoop API. Again, you don't really care how Hadoop distributes stuff, how it chunks files, how it pushes the stuff to workers, how the logic of retrying a failed worker works. You just have mappers, you have reducers, you partition your data, you feed it to Hadoop, and it does all the magic. So these are all the examples of well-designed API. But our topic today is not really just any API, it is web APIs. And why are they different? So let's start. The topic of web API is in some way even more controversial than just API. Because you can think of web APIs as just something that works over internet, some form of API which works over internet. And frankly, there have been numerous attempts to create a silver bullet which will completely solve the communication between server and the client separated by some public networks. Just to name a few, think Java RMI, think .NET Remoting, think Corba, and there were many more. But there are other implementations, and the common pattern you will see is that most successful implementations use the same medium as a way of transmitting information. They use HTTP. And such implementations include XML RPC, JSON RPC, SOAP as a successor of XML RPC. So they all use HTTP as a way of transmitting the messages. Now here we come to our AskGrid. Here's just an example of what does it take to get list of tasks from the API. You send HTTP post request to some URL, and you pass some data in post body. You receive data back in form of JSON or XML. it's basically that simple. So that's the idea of Web API as I understand it. But there are a few gotchas about Web APIs, about HTTP APIs in particular. First of all, as you know, HTTP is stateless. So, for example, when you think about Java API, when you have a list interface, you communicate with some object, with some implementation. This object has state. So you can call a method called size, and it already knows everything it needs to know to give you enough information, because you're calling it on a specific object, you're calling it on a specific state. HTTP is stateless, and so are web services. So in order for web service to work, you need to pass all necessary information to make the decision. So this all necessary information can be as little as an ID of something in a cloud. So, for example, task ID. Here's one more thing. Well, I guess that's really obvious, and I shouldn't state it here, that you cannot pass programming language objects via over the internet. Now, again, this is not entirely true. There were attempts. So, for example, you can think about Java serialization. You kind of, sort of can pass plain programming object over HTTP, but it doesn't really work. But in reality, it sounds like a disadvantage, but in reality, it's a double-edged sword. On one hand, yes, it's inconvenient, so you need to serialize your object to some on-the-wire format, such as JSON or XML or whatever. Then you need to deserialize it. But the other side of this is, it does not necessarily mean that the client and the server should speak the same language. So, for example, your server can be written in Java, and your client, your web client, can be written in JavaScript, and it'll work just fine, because there is this translation layer, this web API layer. One more thing I want to point your attention to, like a subclass of web APIs called RESTful APIs. So REST is representational state transfer. We will speak a little bit more about it. Again, they're stateless, as any web APIs. They usually transmit information over HTTP or HTTPS. They usually expose hierarchical data. At least they work pretty good for exposing hierarchical data. And they use HTTP post, put, delete, and get method. Now, this is where it turns slightly interesting, because one thing I want to talk to you about is how RESTful APIs, why RESTful APIs are different from web APIs in general. So I have a slide for that. First of all, there's a wonderful link, how I explained REST to my wife. Well, I didn't personally explain REST to my wife, but you surely can try. It's a great article. Read it. After I read it, I finally started to understand the bigger picture of what all this is about. But here's a little example. This is just a normal web service API. So there is some script or servlet called user, and to this user you pass some information like user ID and name to modify the username. Well, it actually should be get here. That's my mistake. It works. I mean, many APIs work that way, and it's generally usable. REST API is slightly different, because in REST world, you will have put request for that. And you will have a URL which is, you won't have these ugly parameters such as ID equals, name equals. You will have this ID as a part of a URL, and the data will be passed in an HTTP request body. Same, again, delete. That's probably even better example. In normal web service, you invoke user delete script, passing it some information such as user ID and user group ID. In RESTful APIs, you just invoke HTTP delete method because it exists. And to it, you only pass information it really needs to know, such as user group in URL and user ID. So RESTful APIs are basically web services which use HTTP the right way, the way they intended to be. So, for example, GET is always used for listing entities, and GET is never used like this to modify the data because it's stupid. It's not how HTTP was designed. Because for deleting data, you have HTTP delete method. For updating data, you have put method. And for adding entity, you have insert method. So that's basically the difference of RESTful APIs from any other web services. And in my understanding, it serves a really good goal because it gives you some blueprint, some foundation upon which you build your API, because you don't need to think, how will I call this script and how will I pass parameters? There is the way of doing this. And if you just stick to these ways, your API will be logical, it will make sense, it will be easy to use and easy to understand. So let's move on and let's talk a little bit about what does it take for our API to work. So any API call starts with a request. Request is normally just some bit of data, for example, a user ID or a user ID and the name. So we have this request, and request gets to the web server. The web server can be, well, any web server. Think Apache, think Tomcat. On a web server, after it gets through the web server, it goes through the conversion layer, through serialization layer. So in our example, for example, it can convert data from JSON to Java object, because it's much more convenient to operate with objects rather than with JSON streams on a processing layer. Finally, there's a layer where we process the data, where we process this request, where we do all the modifications, where we communicate to the data store. And after that, it goes pretty much other way around. We convert it back to the message, so to JSON, to XML. We send it to the web server, and the web server replies to client. It should be response here. Well, nobody's perfect. So you can see here a little note that the business logic is really here. And in an ideal world, we wouldn't do this and we wouldn't do that because it's a boilerplate. Pretty much in every project, it stays the same. It can be generalized. It should be generalized. So why you should be doing it? Let's concentrate on this. That's what we will be concentrating on. So, but just to give you, again, a brief outline of what we just discussed, that's what it normally takes to build API in a framework-less world. When you just have a web server, when you just have some language and you have some database. Just read through it briefly. I guess you all can read. It's horrible, really. It means you are getting to this stage after you spend like days, if not weeks, wasting your time on something you shouldn't ideally be doing. That's problematic. And that's where Cloud at Endpoints steps in. Now, to give a little bit of background about Cloud Endpoints, at Google we have tons of APIs. For example, Calendar API, Tasks API, the recently launched Real-Time Drive API. There is an API pretty much for every Google product. As you can imagine, we should have some common framework to build this API on. Otherwise, that would be a horrible, useless waste of time. And about, if I'm not mistaken, about 2 years ago, one smart guy, he said, look, we have this wonderful framework for building APIs. Why don't we think about how can we make it available for our users so they can build APIs using our technologies, using Google's client generation libraries. So, for example, this is basically the programs which take your API description and create a code in Java or Objective-C, which basically makes accessing your API much easier. Why can't we pass it on to our users? And I was happy to see how this project was evolving, how they were trying different approaches. These didn't work, these didn't work, these didn't work. And finally, it started shaping up. So what we have right now is not quite production yet. It's beta. So it probably will change, but we are launching it, and you can already use it. So these examples we're doing here, you can go home and you can play with it. You can use them. So let's build something. Now, a little bit about assumptions I make here. First of all, I assume you know a little bit about Python, HTML, and JavaScript. Really, a tiny bit. If you don't know any Python, again, it's fine, because Python is very explicit, and you can read the Python program as a text in English language. I assume you know a little bit about Google App Engine, and I asked Dell to give you some background reading on that. because I won't be giving too much details about how App Engine works. And again, you will need a basic understanding of HTTP. I mean, understanding what is HTTP is probably enough. So let's move on. So this is how we envision users of Google Cloud Endpoints. So you have your backend running on Google App Engine. So it does not mean that all your functionality must be in Google App Engine. So for example, if you are using some high data crunching or you need some serious storage, you can use Google Storage, or you can use Google Compute Engine, or you can use Google Cloud SQL. But the App Engine will act as a layer between this data crunching and the user. Or, for example, for some applications, like the application I will be giving you as an example, everything can be implemented on App Engine. That's fairly straightforward. You have your clients. You have web clients, Chrome. You have iOS clients. You have Android clients. And you have many more clients. You can have, for example, Internet-enabled TVs as a client. All of them will use the same API. Well, same but slightly different. We'll talk about it a little later. And we'll have a cloud endpoint as a layer between them, which basically makes communicating to this App Engine instance more seamless. So, for example, when you're writing an Android program, you will be using Android framework for authentication. You know, on Android, when you want to authenticate on a Google service, it just lets you to choose Google account and say, yes, I'm fine authenticating with this account. On iOS, you will be writing your program in Objective-C, and you will be using Objective-C classes rather than some weird JSON entities. And on Chrome, you will be using JavaScript client, well, on any web browser, really. So Cloud Endpoints will handle this conversion for you. So here is a problem to solve. Now, when I first approached this lecture, I was thinking, what should I use as an example? You remember I started with asterisk tasks. It looks like a fine example. There's one little problem with it. Pretty much every book on a subject uses one of the two examples. It's either notes or tasks. I thought it's lame. And it's just boring. Everybody's using it. And then I thought, I have a little pet project. It's not quite open source yet. It will eventually be. It's a home automation system. So I have a bunch of sensors installed in my house, and they talk via RF link or via Wi-Fi. They talk to a home server, and this home server talks to App Engine application, and, well, we do some monitoring, some alerting, and whatnot. And as a part of this application, I wanted to enable and disable sensors remotely. So, for example, I may want to disable all sensors, or I may want to disable temperature sensor in a bedroom, or something like that. Or I want just to see all sensors on one screen and see what their statuses are. And finally, I want to control this from the web browser and from my Android phone. And so that kind of can work. And another thing came into my mind is when I first started doing this web controlling thingy, I started with that horrible-looking web service API when I had a couple of servlets, one for creating a new sensor, one for listing sensors, one for deleting, one for enabling, one for disabling. So pretty much the worst possible way you can do this. And then I just realized it can work to a mutual benefit. I can switch my project to Cloud Endpoints. It can be much more simple, and I can use it as a fine example for you guys. So that's basically what we have, and that's how it's going to work. As I said, we have sensors such as motion sensor, temperature sensor, light sensor, well, I don't know, think any. We have a home server. Well, the home server is really Raspberry Pi, which connects to Wi-Fi, and it has a little RF receiver which receives the data from the sensors via RF link. The Raspberry Pi speaks to App Engine over the internet, and my Android phone also speaks to App Engine over the internet. That's basically how it works. How it's supposed to work anyway. So do you remember that long list of what does it take to build a web API I gave you a couple of slides ago? Now, that's what it takes to build a Cloud Endpoints API. So you start with defining the data model. The data model, well, that's basically, data model is a thing everywhere. This is the data your application will operate on. In App Engine's case, this is also the way you will be storing this data because, for example, if in App Engine the logical data model and physical data model very often are the same thing. Then you define your web service interface, well, logically mostly. So you just say, we will have this method, that method, and this method. They will do this, and that. Finally, you implement a conversion bridge between RPC and datastore layers. Well, that's one of these boilerplate things which can also be generalized, but I thought it's probably not worth it, and you will see why, because this conversion is really primitive. And after that, you implement the business logic of your web API. Now, these 3 steps, when I started doing this example, they took me something between 35 and 50 minutes to go through all of them, because it's straightforward, because it's simple. Now, let's go and define the data model for our application. Some code, yay! So here we define the class called sensor. You see, it's defined in Python. It's really easy to read, and it's really easy to understand. We just define a class which has 5 fields of type integer, string, 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 boolean, and that's basically it. You have just defined the logical and physical schema of your database. You can do this because, see this. We inherit this class from DB model. This is the class provided by App Engine framework, and we create these fields as DB properties. That's it. That's basically enough for App Engine to handle this serialization for you. And we define sensor ID as a unique field, but that's pretty much arbitrary. Now, the next step is we define our web service API. But really, first we start with defining the sensor message. So how this data will be sent to us. You see, it looks really familiar to what we had on the previous slide. So we define a class we inherited from message. Now, this is a class provided by Cloud Endpoints framework. We define the same 5 fields, basically, although the types of the fields are different. There are integer field, string, 2 enum fields. Well, I just use them as an example, and a Boolean field. Now, one little thing here is you can see that every field has got a number associated with it. What does this mean? Has anyone here dealt with protocol buffers? No. Okay, so basically, when you send information over network, over internet, you need to choose a format in which you will be sending this data. It can be XML, it can be JSON, it can be pretty much anything. At Google, we deal with unbelievable amounts of information, so pretty much every byte counts. So at Google, we built a library, a framework called Google Protocol Buffers, which is basically a very, very efficient way of serializing data. So on one hand, it can serialize data to a format which is very similar to JSON. Well, it was influenced by JSON. And it's really useful for debugging. So, for example, you can take this message and you can print it out. You can read it. On the other hand, you can take this message and serialize it to a binary format. And in this binary format, unlike XML and JSON, we actually skip all field names. We skip all empty fields. We skip all unnecessary information. And as a result, this format is about 4 times more compact than JSON and takes about 30% less time to serialize and deserialize. So basically, these numbers are used in protocol buffers. You may ask why we will need to use protocol buffers here if we're building web client, which means we will be speaking JSON anyway. Yes, we will be speaking in JSON, but if you are building a mobile client, now, the mobile phone usually lives on a pretty weak data connection with a very high latency. So again, every byte counts. And in this case, we want to squeeze as much information into as little pipes as possible. So if you will be using a client library for Android or iOS, instead of using JSON, in reality, it will be speaking to Google Cloud Endpoints using protocol buffers. But you will never know it because it will handle all the conversion for you. Okay, and the next step is defining the conversion layer between RPC and data. Do you remember why I told you it wouldn't take long? See, I even had to include the comment here because otherwise it was, 6 lines of code that just looks too lame and too unimpressing on a whiteboard. So that's basically it. You take one object and you create other objects from its fields. This is it. It works in other directions pretty much the same way. And if you have lots of different message types and you have lots of different data types, you obviously can generalize it. So define some common conversion layer so you don't need to do this at all.
Is obviously the only message layer you can use, or can you use JSON?
Can you use JSON where?
In the previous slide, do you have to use ProtoRPC, or can you define proper mediums of?
You will need to define your message that way, but you can speak to the web service using JSON. And in fact, you will speak to web service using JSON. You will see it fairly soon. But that's Cloud Endpoints' way of defining a message, so it can handle serialization for you. Okay, and now let's finally give you a couple of examples of how can you use it. Now, I will not give you the full code because it's just too boring, and frankly, it's pretty much the same code everywhere. So I'll give you an example of insert method. So here in insert method, we have a request. I guess I didn't include the type of a type sensor request message, which inside contains a collection of sensors we want to add. So you see it here in request sensors. So basically, that's the code. We go through this collection of sensors passed to us in this request. We check if this sensor doesn't exist in our data store. And the code which really matters here is this. You create a new sensor entity, and you invoke method put on this entity. That's all it takes to store data in App Engine Data Store. All other methods work in pretty much the same way. Okay, so let's think what we've done. We have defined a data store model, we have defined an RPC model, and we have defined a conversion layer, and we have implemented an insert method. The last bit we have to do is to wire it all together to make sure it all works properly. So here we have 2 bits of code. First code is the definition of our service. This sensors API class will contain methods insert, delete, list, and what was the other one? Update. Here we have a couple of annotations. So first we define the API name, sensors. Second, we define the version of this API. Now that's an interesting thing. When you in the real world, when you deal with real users in real production, very often you have to support 2 and sometimes even 3 versions of your API at the same time, because some clients are just too lazy to migrate. Some clients are stable, and you are building the next version of the API, and you have some clients who already want to be on a bleeding edge, who want to use the most recent version of your API. So as a result, you have 3 versions. Maintaining it in a normal service is a huge burden. It means you need to configure your server so requests on /v1 are sent to this version of servlet, the request to v2 sent to that version of servlet. Cloud Endpoints handles it all for you. So you can have just a couple of classes, named, for example, sensor API v1, sensor API v2. Actually, you can name it whatever you want. As long as you have this annotation here, Cloud Endpoints will convert, will map the appropriate URL, will map it to a specific service class. So that's how you define the main class, the service class. And this is, you remember our sensors insert method. This is the annotation for the insert method. Here you define sensor request message, sensor response message. Those 2 are request and response type. you specify the path to this will be sensors. You specify HTTP method you will use. Now, you remember I told you that for insert, you conventionally should use post in RESTful APIs. So in cloud endpoints, it's not that you must use it. So you can pass the data here using HTTP GET, although it will look ugly and would not make much sense. But cloud endpoints allow you to do that, although it's much better just to use the methods which are supposed to be used. And this is basically it. So let's go through these little things again. We defined the data model. We defined the message. We defined the conversion layer. We implemented the insert method. And we added a few bits of annotation to make sure they all work together. Now, well, obviously, there will also be methods list, delete, update, which will be included into the source code I'll provide you, but probably a bit redundant here. Now, let's get it started. So here's Google App Engine Launcher. It's a really, really simple UI which allows you to create new App Engine application, to launch it, to view logs. So we have it started here. It's running. Now, first thing you will probably use is, when you create your API is Google API Explorer. Now, you remember I told you that we have a lot of very usable and nice tools for using our APIs at Google. Google API Explorer, initially it was created so our users, our developers, our external developers can look at our APIs, can play with them, can see how they work, can see what data they can pass to make it work, and what not. But because we were building cloud endpoints on the same technologies we're building Google APIs, it was fairly easy to adapt it and to make Google API Explorer works with the cloud endpoints API. So we have our API launched here, and you see the top, on the top level we have Sensors API, V1. Now, we click the Sensors API, we move on. Here we have our API methods. So delete, insert, list, and update. All this documentation is automatically generated from Python comments you put under the method. So you know, free quotes, comment, free quotes. It will all automatically make it here so your users can see it. Now, let's say we want to insert a new sensor. We click Insert method, and here it gives us a really nice UI in which you can build your request. Answering your question, you see that you are building it, in fact, in JSON format. The reason for that is, as long as you are speaking to, let's put it this way, web gateway of this API, you will be speaking in JSON. So here we define our sensor, we define a network ID, we put the strings for enums, and we click Execute. Now, when you click Execute, you will see two things. First of all, it will build the request in JSON format, and it will show you where it is sending it and how it is sending it. So here it says that I will post this data to this URL. Okay? It gives you a little bit of headers, of request headers. So the content type is application JSON, and the user agent of whatever we're sending it with. And here is our message in plain, normal JSON format. And the server replies HTTP 200. Okay, everything is fine. So, and just to confirm it, it returns a tiny little payload saying status equals status OK. That's it about calling API from API Explorer. But one more thing I wanted to point out here is, to use web APIs, you don't need API Explorers. You don't need fancy client libraries. In fact, you don't even need a browser. So here, I'll give you a small example of how you can do exactly the same thing from a command line using standard CURL command. Here you specify same headers as we did before. So we say content type application JSON. We say that we will be posting data. We specify our payload, so the JSON message we are posting, and we specify our URL. we hit enter, the server replies with status OK. So you can do the same thing from a command line. It's very useful if you want to do a little hacking. So for example, you want to create a task which will launch every hour and fetch some data. It's very easy to take this and put it on cron, so it will start automatically from a command line. No UI needed, no browser needed. You don't need anything. You already have everything here. Okay, now let's talk a little bit about how you can consume this in real world, how your users will consume it. Let's build a web client. So we have, imagine we have an HTML file. In this HTML file, first in the head section, we put this script. Here we just download some script from APIs google.com, JS, client.js. As you can see, nowhere we say that it's our API. Nowhere we say it's a Sensors API. Nowhere we say it's a cloud endpoint. In fact, if you take at any web client which uses any other Google API, you will see exactly the same line. So we use same API client, same JavaScript API client, which is used for every single Google API available. And here we give a little parameter onload equals init. This means that upon loading, this script will try to launch a function called init. It's up to you to define it. That's basically an example of this function. So the first thing we do is we call Guppy client load. Now, here we actually load the API from this URL, from root URL. If you're interested in what happens inside, what it does, the cloud endpoints will generate a huge, or not so huge, JSON document called discovery document, which gives exact information about every method in your API, about every parameter in your API. If you define it, it'll give you some type checking. If you define it, it'll give you some data checking. This JSON file is generally human readable, but no one really needs to read it. So here in Guppy client load, what we do, we load this file and ask API client to initialize using this client. And upon loading, it will launch this anonymous function, which will launch list sensors. So we can start using API. Let's take a look at this. What? I did everything right. Let's take a look on how we will create a sensor. You remember we did it in API Explorer and in CURL. Here we do much the same, except now this is a part of a real code, which is an example. So here I choose random values for sense ID, random values for network ID. I pick random enum for the room where it's installed, random enum for type, and so on. So we just create some sensor, and we create a request. In the field called sensors, we specify a list of one element. So we can create, for example, 10 sensors here and specify a list of 10 elements. We can pass all of them in one go. And here we call Guppy client. Now, before we started, these Guppy client sensors didn't exist. But after we loaded it here, it builds it automatically because it's JavaScript. It's really easy to do it. It builds it, and the namespace of sensor starts to exist, and the function insert starts to exist. So we call insert, and finally we call insert specifying the request we want to send, and finally we call execute specifying, again, another anonymous function, which will just list sensors on the screen. So it's pretty straightforward, just a couple of lines. Everything is boilerplate, except obviously of this. Just a couple of lines. Now, let's finally take a look at this list sensors. Again, it's fairly simple. The same standard, Guppy client sensors, but now we call method list. And again, in execute, we pass a function which will take the data, which will be already not in form of JSON, but in form of a JavaScript object, so it will be parsed JSON, and basically builds the table from this data. That's as simple as that. Let's take a look at update method. So let's say in update we want to toggle activity status of a sensor. There you go. So here's our function, toggle active. and we define a request, sense ID equals pass sense ID and the activity status. In exactly the same manner, we execute it, and we update the list of sensors. Now, I have a tiny little demo, I hope it will work, which will illustrate how it will work when you launch it at home. Oh God, let's hope it works. Please. No? Oh, it's loading. Wonderful. Hey, here we go. So we create a bunch of random sensors. Then we start playing with statuses. And then we finally delete it. That's basically it about this example. It's really primitive, but you will see the source code. You will see how it works in reality. Now, obviously, we don't have enough of time for that, but I still want to reiterate here that cloud endpoints will not only work with web applications, it will also work with Android, and you will have a native jar produced by the client library builder, which you just connect to your project and start using it. It will work with iOS, although I haven't tried it. Furthermore, for Google APIs, we have access libraries pretty much for every language in existence. So for all dynamic scripting languages, such as Python, PHP, and Ruby, again, it will just work. And finally, it will work with every single platform capable of making HTTP calls. So if you don't have a client on your platform, if you, for example, you're writing a code on Arduino, you still can do all the same just using plain HTTP queries. I guess this is it. And if you have questions, now's the time.
When you connect, assuming that you have a solid-state relay connecting your electrical access, and you have maybe a low-level processor like Arduino to read data. So when Arduino passes data to the Google App Engine, so who are the ones that brokering the data transfer?
Oh,
this is the thing I try to map out the picture.
The Arduino itself doesn't pass data to App Engine. Arduino passes them to Raspberry Pi. Raspberry Pi yes, it acts as a broker. It accumulates this data, and even more than that, because Arduino is stupid, it basically passes data all the time. It's just if we want to act on this data, if the sensor is active, or we want to ignore this data. Well, obviously, we can send message to Arduino from Raspberry Pi saying, now shut up. I just haven't implemented it just yet because really communication only works one direction now. Don't know why. But Raspberry Pi acts as a broker here. Okay.
Authorization and authentication.
Oh, that's a great question. I expected it. So if you played with App Engine, you know that you can easily authenticate your users using their Google account. It will work exactly in the same way for cloud endpoints, except if it is a web application, you will just pop up a window with a Google login page asking, and now please log in. Once user is logged in, effectively you have a cookie set on accounts.google.com. The API will work as it's authenticated. On Android, it will ask user to log in. First, it pops up a list of his Google accounts, if there are multiple. He chooses an account, for example, I choose Kirillov@google.com. And then it shows the page saying, do you want to allow application X to access this, and this data on your account? You click allow, and again, you're authenticated. On a cloud, on your API set, basically all authentication is handled by exactly one line. You say something like authentication equals required, authentication equals optional. Something. So it's basically, it's really one-liner. You don't do anything. Everything is done for you. On iOS, it also works somehow. I'm not sure. Anything else? Okay. Sure.
About the data that you store, if you wanted to manipulate that data and report it, I mean, how
report on the data as in
Encoding information.
Okay.
And that's going into a black hole, as far as I can see. And I'm curious to know how, if there were hundreds of thousands of records, how would you query them? And what happens when the database starts to become really complicated?
Okay, so there are several answers here. The first answer is App Engine provides really extensive framework for manipulating the data. So you can query data using, well, a sub-dialect of SQL. You can query data using things like filters. It's an App Engine concept. So you can build pretty much any report in form of web page or CSV file. Now, if your data grows really big, you can think about using things like Google Cloud SQL. Although, well, I guess it's not entirely true. If your data grows really big, you probably want to keep using App Engine, because the way App Engine data store works, it's built upon our technology called Megastore, which, for example, it handles Gmail. So all data in Gmail stored effectively in the same data store which App Engine uses. On the other hand, if you want to do some very SQL-specific analysis, you can create a bridge between Google Cloud SQL and the data store, and you can analyze it in Google Cloud SQL. Furthermore, if you accumulate the data and over time you have accumulated like some significant amount of data, say, well, 100 terabytes, you can export it either record by record or in batch to a thing called Google Fusion Tables, which is built on a Google technology called Dremel, which is the technology we use to analyze the logs. So basically, when we need to query not just hundreds of megabytes or gigabytes of data, but when we need, for example, to query 500 terabytes of data, we use this technology called Dremel. It is also available to App Engine, and there are bridges which would allow you to communicate from App Engine to Fusion Tables. There are also other options, such as Google Cloud Storage, but that's probably more about storing static content, binary data, and so on. Does that answer your question?
Yeah, that's fine.
Okay. Come on.
What data formats are supported? I mean, obviously JSON and your own specific type thingy. But apart from that,
out of the top of my head, right now, this is it. But you should still consider that this technology is early beta, and it will evolve, it will change. But what other formats you mean here?
Actually, I was probably thinking more of completely custom formats. What if that's possible?
Completely custom formats?
Yeah, pretty much. A lot of old hardware sending bit streams, pretty much.
Oh, okay, I see. Like well, one option here is, say if you have a stream of binary data, you can define a message in this ProtoRPC format with a single field called data, which will be, for example, base 64 encoded binary stream. But obviously, you need to do all serialization, deserialization yourself. So you will send base 64, and on the other end, Google Cloud Endpoints will give you base 64. From there, you're basically on your own. But this is actually the way it works when we need to store large amounts of binary data. We just create a string field in protocol buffer and dump however much it takes. So in a way, it supports other formats, but serialization is up to you.
Underneath it all, is it virtualized?
Underneath it all, it's
in the same sort of vein Amazon is.
No. It's other way around. Well, at Google we have probably the biggest in the world grid computing system. I actually don't remember how much can I tell you about it, so I'll tell a little bit. When we deploy our software, we don't deploy it on a server. we're just saying that we want to deploy this task. And we deploy it, and from there on, we don't care on which machine it will execute. If this machine will fail, it will this task will be automatically relaunched on other machine. So, and App Engine is powered by the very, very same grid. It's just a segment of that grid dedicated for App Engine. But basically, it's powered by the same grid technology as any other Google project. It is not quite the same at Amazon, because from my limited exposure to how Amazon works internally, they have some sort of grid, but they also have a lot of just virtualized instances, like very much like EC2. But the difference here is, with EC2, they give you an instance. It's just a computer-ish running somewhere. But that's basically it. It's just a machine. You can do anything you want there. With the higher level systems, such as App Engine and technology it relies upon, you don't have machines, and you don't care about machines, because machines are unreliable. And on the other hand, for example, if on EC2 you need to span your task over like several machines, you need to do things like load balancing, communication, all that kind of stuff. You need to bring more machines. In App Engine, how it works is you just set maximum amount of money you're ready to spend in a day, and it will automatically bring more instances, more computing instances, because, in fact, it doesn't bring up any physical machines, or any virtual machine for that matter. It just deploys more tasks somewhere in Google Grid. And that's the way it works at Google internally. If we need more shards, as we call them, these little instances, we just specify that shards goes up from 10 to 100. And immediately our job is spanned across 100 machines. So it's not quite Amazon. Yes, you.
Do most of your products run on Google App Engine, or are you using...
Off the top of my head, about... no, not all of them. About 10% of our products run on App Engine. Basically, this is because on App Engine we launch the products which do not necessarily need to speak to other parts of our production infrastructure, such things like as a big table, as Megastore. So, for example, if we are launching just a service which will only speak to some RPC server inside of Google, and that server will handle all heavy lifting, yes, we will launch it on App Engine, and in fact, it's encouraged. So, when we launch anything at Google, you need to fill in a little launch questionnaire. And one of the questions is, have you considered launching this on App Engine? Yes, no, why no? So if it is possible to launch it on App Engine, yes, we do that, because basically App Engine, because it's high level, it removes even more burden of your shoulders. Sometimes it's not feasible. Sometimes it's a mixture of both. So we launch the front end on App Engine, and the back end, the RPC server, it speaks is inside Google Prod, and we speak to it using this protocol buffers RPC protocol.
Those are the exact questions. So.
Okay, good.
You mentioned that Endpoints can be used in Android programming as well.
In where?
Android.
Oh, yes.
So is there a specific feature for that, or?
Well, yes. There is a program called Library Builder as a part of your cloud endpoints distribution. Well, it's not a distribution, it's just a download somewhere. It's basically a jar, an executable jar. To this jar, you give this discovery document. You remember I told about it. First, you generate this discovery document. It's just one line call. And then you feed this discovery document to this program, and it generates you a jar, which you deploy to your Android project, and that's it. You have a fully featured Android library. So you just, which is, well, just like any other Java library. It works same way with iOS, supposedly. Okay?
Can I ask you a question?
Yes, you can.
You mentioned about reversioning, different versions of the service. What is the suggested recommended way to deal with that? Does it mean that I have to deploy several services
Well, the recommended way of dealing with this is exactly as I specified there. So you just use different version annotation, and that's basically it. You don't need to deal with it. It's already dealt. So, and then in client, you just specify that instead of V1, I want to load V2 version of the API. Again, that's it. So all the magic happens inside Cloud Endpoints. Okay, anything else?
So the code is open source.
Well, it will be open source when I polish it a little bit up. Right. So I hope this thing was yes, this thing looks like it was recorded. So I will upload it to YouTube, and I will polish the source code so you can play with it. You can launch it at home, and you probably can build some new exciting projects with our technology, which will make me very happy. Thank you very much for coming. It's been a pleasure.